I'm Giorgia Pagliano. I'm the environmental engineer of the B-Plas team, and I'm going to show you the technical aspects from the pilot plant to the full scale that we are designing now. As Alice has told you, the main focus of B-Plas is to convert the sewage sludge into bioplastics. So we started as a university project, and after that, with the support of the acceptance group, our startup born during the it's just one year that we are a really startup. So the main focus of B Plus is to convert the sewage sludge into bioplastics. The kind of bioplastics that we produce is the PHAs. Different kind of bioplastics are present, but not all of them are biodegradable. So among biodegradable and bio-based plastics, PHA achieved around 1.2% of the European production, and PHA are polyesters produced by bacteria as energy storage, and are really important because they have thermoplastic and chemical properties similar to the traditional plastics. So the main obstacle to the world diffusion is the high production cost that now is around 6-7 euro per kilos due to the not sustainable production chain of PHA. The problem is that PHA on the market are produced using single microbial strain. The single microbial strain use the pure substrate for the PHA accumulation, and so in this case, sterile conditions are required, and it takes really high costs. In the B-Plus process, one of the key factor is the use of mixed microbial culture. So the mixed microbial culture are the consortia of bacteria selected by the activated sludge of the wastewater treatment plant, and the MMC are able to metabolize organic waste as substrates, and sterile conditions are not required because, of course, they are already a consortium of bacteria, and they can metabolize organic substrates. And in particular, in B+, we use volatile fatty acid as substrates. So it means that this kind of bacteria are able to metabolize different carbon source, but of course they also are able to produce different kind of PHA, so different kind of copolymer. The feast and famine condition is the key for the PHA accumulation. So the bacteria are subjected to a selective pressure that is related to a cycle of feast when the bacteria feed with the carbon source, and with cycle of famine when the bacteria work without carbon source, and so they work under limiting condition, and this stress condition allow the PHA accumulation. The PHA produced by B-Plus process can reach a competitive market price thanks to three key factors. So first of all, the sludge as starting feedstock. So the sludge actually is a cost for company, for agro-industrial company, for the utility and multi-utility working in the waste management, and that's what we use as feedstock. So we can valorize this feedstock. The second key factor is the use of mixed microbial culture, because it's more easy to manage the process with mixed microbial culture. They are most flexible and permit us to metabolize the organic waste. And of course, the extraction. The extraction is one of the more impact costs on the final price of the PHA. And we designed a sustainable PHA extraction method with using the dimethyl carbonate, and it's sustainable for many reasons. First of all, because we have a system that reuse many times the solvents, and we are a really low dispersion of the solvent during the extraction phase. So these three key factors allow B-Plas to have a market price of the PHA that can be around 3 or 4 euro per kilos. Alisar already showed you this simple scheme, but let's go more in details. That's the scheme of the B-Plas process. So first of all, we have the feeding tank with of course the input sludge. The first two phase are a pre-treatment phase with a mesh grating and the grinder. Because we have to reduce the particular size in the sludge. So after that, we had the really first phase of B-Plas, the thermal process of hydrothermal carbonization. Here we have around 200 degrees with a pressure that can be up to 20 bar. HTC is aimed to the solubilization of organic matter because, of course, the key factor of B-Plus is the use of a sludge that is not so be cannot be used for any biological transformation because it's already stabilized. It cannot be used for any transformation, and so we using the HTC we allow the solubilization of organic matter because we have one a main factor that is the COD. The COD is a parameter related to the organic matter in the sludge, and using the hydrothermal carbonization, we solubilize it up to 50% of the organic matter. So this soluble COD is available for biological transformation, the biological process after the HTC, that is the anaerobic digestion. So the COD solubilized is converted into VF phase through anaerobic digestion. In this phase is not aimed to produce biogas because we are focused on the VF phase production because as we told you, the mixed microbial culture are able to metabolize VF phase. So anaerobic digestion is operated under thermophilic conditions. So we are around 40, 45, 50 degree, and with a really short rotation time because of course for the anaerobic digestion we need a really long rotation time, but if we want just to obtain high VF phase concentration, we have to focus it on really short rotation time. So in the anaerobic digestion, we have the VF phase production. After that, we need to separate, of course, the broth rich in VF phase and the solid part. So in this phase, we have a filter press of the DM filtration with, and so we have cake, so the hydrated sludge, and usually we achieve around 35, 40, 35, 45% of dry matter in this output flow. So it means that for a company, we achieve a reduction of the input sludge around 70%, with a really high impact on the core business of a company. So in this phase, we have solid liquid separation. So the solid phase is the cake, and the liquid phase is flow, is a broth really rich in VF phase, and is perfect for feeding the mixed microbial culture. So here we have, in the specific, we have two different reactors because usually the PHA are selected in a reactor, so a reactor that is aimed to the selection of the bacteria, and another reactor aimed to the production of PHA. So usually in B-Plas we work with a reactor operating under anoxic condition that is aimed to increase the PHA percentage in the microbial culture, and another reactor operating under aerobic condition aimed to the selection. But of course, both of them working under feast and famine regime, and they work in the continuous mode. After that, of course, when we have a slurry, when we have the biomass enriched with PHA, we have to extract. One of the challenging aspects of B-Plas is the extraction operated on site. The extraction in B-Plas, as I told you, is operated using a green solvent, the organic solvent of dimethyl carbonate, and we have a different system for the recirculation and different filters that allow the separation of the biomass and of the dimethyl carbonate. We have a different solution for this module, and we are managing a different solution for the optimization of the reuse of dimethyl carbonate and to optimize the final PHA obtained. But of course, at the end of the process, we are able to obtain PHA as chips or as pellets, but we obtain that PHA on site. So we are managing an extraction module operating on continuous mode under continuous condition.